Before we look at calculating elasticity of demand, we just want to take a look at some example outputs and focus on the interpretation to get an idea of what these numbers tell us. So in example 2, we want to complete the following assuming the elasticity result below has been found. So we found E of 26.87 is equal to 0.34. The value that we plugged into this function, 26.87, or that was plugged in, is the price point, P. So that's essentially saying we're charging $26.87 for that item right now. Then we end up with a value for E of P, which in this case is 0.354, meaning that in this case, our elasticity value is strictly between 0 and 1, and we refer to that as inelastic demand. This tells us that if our price increases by 1%, then demand, which has an inverse relationship with price, will decrease by E of P percent, which in this case would be 0.354%. In this scenario then, what we're saying is that if we increase price, demand will decrease. There's always that inverse relationship, but that decrease in demand will be smaller than the increase in price. So even though demand has dropped, we're making more per product. So in this case, we increase our revenue by increasing the price. In example 3, we have a value where our elasticity is equal to 1. Anytime we have an elasticity equal to 1, we refer to that as unit demand, or we could say that demand is unitary. In this case, we're saying that if we increase price by 1%, demand will still decrease because there's always that inverse relationship by E of P percent, which is 1%. That is, the increase in the price by 1% causes demand to decrease by 1%, so there's no change to our revenue in that case. So if we increase our price, we're making more per item, we're selling a little bit less, but since that change is equal, those two things cancel each other out, so that increase in price yields no change in revenue. And we refer to this price point, where we get an elasticity of 1, as the optimal price point. Because increasing or decreasing our price would have no impact on revenue. In example 4, we have an elasticity value that's greater than 1. We refer to that as elastic demand. So in this case, if price were to increase by 1%, demand still decreases. And in this case, by 1.949%. So that decrease in demand outweighs the increase in price. So that means that increasing our price will will result in a decrease in revenue. Or we could flip that around and say that if we decreased our price, we would increase our revenue. Those three examples then outline how we'll interpret each of our different types of elasticity values. And we can see this in example 5. If we have each of the different elasticity values that were calculated, and we find that E of 83.23, meaning we're selling our product at a price of $83.23, if our elasticity is equal to 1, that means that demand is unitary. If demand is unitary, then $83.23 is the optimal price point. A change in price will have an equal change in demand, meaning no change in total revenue. If our value for elasticity is 0.3482, so something between 0 and 1, then we would say that demand is inelastic, which means that increasing our price would actually increase revenue. That is, we can charge more for our product than we're currently charging. And in part C, if we end up with an elasticity value like 3.1178, anything that's larger than 1, we would say that demand is elastic, which would tell us that we want to decrease our price to increase revenue, because the lower price will be met by a larger increase in demand, so overall total revenue will increase.